Okay, let's talk about variations of the equilibrium constant with the form of the balanced equation. So let's look at the reaction we looked at in the previous video. From example 15.2, we had the equation PCl5 in equilibrium with PCl3 and Cl2. So we said that the Kc was equal to the concentration of PCl3, Cl2 over the concentration of PCl5. And we determined that equilibrium constant to be equal to 0.53. So what if we change that up? And in our case, we're going to reverse that reaction and put it the other way. So instead of PCl5 on the reactant side, now it's on the product side. So I've done sort of a switcheroo. We're going to use the concentrations from the previous example, 0.172 molar for PCl3, 0.086 molar for Cl2, and 0.028 molar for PCl5. And we'll see what the equilibrium constant of this new reaction is. And we'll draw some conclusions. So let's look at that on paper. And I've already copied a lot of this information over. And so if I write the equilibrium constant for this new reaction, our equilibrium constant is equal to what? Now the concentration of the PCl5 is in the numerator, the PCl3 and the Cl2 concentrations are in the denominator. So if we plug in chug now, PCl5 is 0.028 molar. And then the PCl3 0.172 molar. And chlorine 0.086 molar. And so our Kc, based on that reaction, we're going to run that through our calculator, 0.028 divided by 0.172 and 0.086. And so we get we'll go 2 sig figs, 1.9. Really it's 1.8929, but we're going to round off to 2 sig figs. Now, what you notice is that this Kc is the reciprocal of that one. So if we call this Kc prime now, because it's for the reaction written the opposite way, just to distinguish the two, that little apostrophe or diagonal dash indicates it's an alternate value, so we call it prime. And so what we say is that Kc prime is equal to 1 divided by Kc. So it's the reciprocal if you write the equation the other way. So we say 1 divided by 0.53. And so we run that through our calculator. And guess what? We get 1.9. Same value. And so what you can see is if you write the reaction in the reverse order, you do in fact get the reciprocal. And so you can do less math and just do the reciprocal if you've got the value without doing a bunch of extra math. Another thing to remember is that large equilibrium constants equal product favored reactions. Small equilibrium constants indicate that only small amounts of products are formed. Generally, equilibrium constants greater than 1 end up being product favored. The bigger that number is, the more product favored it is, until eventually if you get some enormous equilibrium constant, we'd say that was more of a one-directional reaction than an equilibrium. And if it gets increasingly small, we form very few products in that equilibrium. Looking back at our problem, we can see that when we take the reciprocal, we get 1.9. So its product favored, favoring the formation of PCl5. You still favor the formation of PCl5, but since this equilibrium constant is less than 1, we assume it's reactant favored.